Muy buenas tardes.
Hello, good afternoon, everybody. My name is Charles Saramoto. I'm from the Banco Santander in Chile. We now have a very special guest, Nicolas Corrarello, who's the Senior Director of Solutions Engineering at HashiCorp. I'm now going to give him the floor. Thank you very much for being here today. You have the floor. Well, thank you very much, Charles, and many thanks for that very warm introduction. Good morning, everybody. Today, we're going to be talking a little bit about computer safety, or IT safety, rather, and I'm going to be talking about the architecture. And with a bit of luck, thanks to the experience that HashiCorp has had over the last few years. But when we talk about this, what is it we're talking about? We're talking about a change of paradigm. And as I always say, between inverted commas, safety at these centers used to be relatively easy because it was inspired by what had to do with physical security, with the physical security of any building, where basically we have four walls that defend us against the exterior, and we have a number of physical doors that protect our computational assets. And after 40 or 50 years of IT history, what we have done is applied those principles. We have created logic networks that separate the access to processes like militarized areas, for instance, and secure areas where we store information. But we're always talking about the four walls of the perimeter of the security officer that I still use for a presentation. And I suppose that if he sees that I'm using his picture, he's going to ask me why. But we consider this security as human beings. However, the truth is that the paradigm has changed in recent years. And if we go directly to what it is that brought about this change of paradigm, it's very straightforward. And it's the use of cloud computing. And this changed what we consider to be the perimeter because we couldn't touch our perimeters. We have disks that store information that comes from third parties. Our information flows through third-party networks. So all the controls that we can apply at the end of the day are just logical. They're not physical because we no longer have that control. We don't control computational resources. And this is how user operations changed and how the user interacts with the infrastructure. Whether we like it or not, the gold standard has been applied by the computational providers. And today, the gold standard is that anybody with a credit card can procure infrastructures at many computational centers all over the world. And what has also changed are the attack vectors on how it is possible to have an infiltration of or leak of information, how this can harm our infrastructure. By delegating the physical problem in favor of a third party, we still have a logical problem, and that is how can we prevent app from being affected or to give access to a database, or if there's information that is leaked that is on a flat text so that it can be easily interpreted. But let's talk about these challenges today. But firstly, and very, very quickly, I'm going to introduce myself. As you've observed by the accent, and Charles has the same accent. I'm from Latin America. My name is Nicolas Corralero. And those of you that speak to me, please call me Nico because it's much shorter. I speak three languages. I have three passports, but I live in the UK, to the north of the city of London. And I usually say that I form part of the furniture at HashiCorp because I'm from the class of 2017 and it's a company that's 8 years old. And it's been a very interesting experience. But on a daily basis, I lead a team made up of about 40 solution engineers that are operating throughout Europe. And I have four managers in each region. Although having started at such an early age at HashiCorp, I've had the opportunity of working with many customers in the implementation of our security projects. And I even wrote codes, which is and nowadays forms part of our security protocols. But as regards my profile, I'm an ex-instructor at Red Hat. and when it was in Buenos Aires, and I was always the administrator of IBM Systems, a support engineer for other companies. And well, at 18 years of age, somebody told me that my official position was to lay cables. But in any case, I've worked with infrastructures, and now I have to do so from a completely different point of view. But please allow me to share part of my experience. And the truth is that if we go back in time and we look into the changes that have been brought about by the expression zero trust, and well, a colleague of mine was reading the English version of this presentation, and his daughter said, "Well, it's not right not to trust people. You must trust people." And I fully agree with that. But when we're talking about IT security, no, because we have to adopt a different position when we protect our information and our resources. And I always try to emphasize these three principles that are the base of zero trust. And the first element is that one, as a systems administrator, if somebody requires access to a database, well, basically you use a set of principles that is pretty extensive, so that there's not a frustrating process involved. But anybody that requires access to a database is given any privilege on any table. But what Zero Trust has taught us is that this is not correct, because if we were to look into the credentials, the only thing that we are doing is extending the problems that this can produce. So therefore, when we talk about Zero Trust, the first thing we have to bear in mind is that when the time comes to giving access to somebody, that has to be the least privilege possible, exactly what somebody needs for that particular purpose, and not extensive capabilities when you administer something or when you obtain information, but rather this be limited to exactly what the user needs in the app. We always have to check. And this is something that, well, when we at the private computational centers, we said, oh, don't worry, because databases can only be accessed through this support and this network. And these perimeters don't exist because we have the physical networks and perimeters. So everything should be checked. And whenever something requires access, it has to be authenticated and it has to be authorized. And credentials must last for the shortest possible amount of time. And this is something that should apply to everybody, really. We generate a new certificate, a new TLS certificate for 10 years. And well, if it's you have to limit the amount of time of validity of something. So you have to issue a credential or a certificate. And finally, we have to be on a permanently defensive attitude, because the network is not reliable. If we're in a cloud, it's not reliable. There are many points of entrance and exit. So everything that is on the network should maintain an offensive approach. And these are the principles that we have applied in the last 5 years. And as I said previously, just-in-time access to a resource is a key element. And all the solutions that we have created, we have tried to create that. And that is a just-in-time access for the amount of time that is necessary. In other words, a specific access to the resource, not extensive capabilities, but rather access adapted to what a person or a system needs. And we're doing this based on 4 basic principles. The first one is possibly going to be very well known by everybody, and that is, how can we authenticate the identity of a person? If somebody has to access a resource, I need to be able to check that person before giving anything or before doing anything. But now that I know who that person is, or once I know what the system does, I need to have other systems that will allow me to give him access to other systems that will mediate. Should I understand whose identity we're talking about and whose system has to be accessed. But when we talk about these mediation systems, and when we talk about limiting the perimeter of access to the greatest possible extent, automation is a term that Argentinians say is very ripe and is about to fall off the tree. And if we have to generate specific credentials for each system manual with a set of permits for this system to be accessed, the investment in people, the investment in time, when these changes are made is not sustainable. So therefore, whenever we think about security and automation comes along, and many of these operations have to be more than automatic. It has to be like breathing for the human body. They have to be completely involuntary. And we are talking about operations, we're talking about authentications of systems and accessing systems through networks. And we're talking about or mutual TLS or encryption, in-transit encryption of information, because we've been told that the platform is supposed to provide this. And finally, we have access control of people to systems due to administrative requirements or due to, well, because you have to consult information. So all of these things should be fully automatic and should generate the least possible inconvenience in the case of developers or the people that maintain systems. But let's look into these concepts into much greater depth. Possibly the most commonplace concept that you know about is the concept of how can I authenticate and authorize somebody. Well, basically, how can I establish the identity of the user? This hasn't changed very much since, many years back, or at least since when I started to work with Comput. I initiated an Active Directory with users and passwords, and all systems can use that as a center of trust to authenticate users. But as this system has become much more complex. What we have noted in organizations is that there are multiple active elements. Well, there are replicas, and as these technologies required, well, they had to be looked into, and we've introduced federated identity systems like Okta or PIM. What we're doing right now at the data center as regards the management of secrets and the management of networks also have to evolve. And here we have HashiCorp that we appeared about 5 years ago with three products that I'm going to be describing now. But I don't want to focus very much on the products, but rather I want to focus much more on the design principles of these products, because this is perhaps the common knowledge that is applicable to any product or to any application that is being developed. And I would like to kick off by talking about Vault, which is a very well-known product. But what was the problem that Vault want to solve? Let's say that when we look at the existing apps in networks or in computational networks, what we find is that basically there is the concept of a user and a password for a main account or for a service account to access some systems. But let's say that the perimeter is established in the network and all of the security is purely in the network. But if we move on to the requirements that current clouds have, as mentioned previously, we can find that the network is managed by somebody else, by a third party. And what we have to do is we have to rely on the concept of the virtual machine identity, or whatever it's called by the cloud provider. But these entities, perhaps the most interesting concept is that this only exists within the control plane of Amazon or the control plane of Google. In other words, this doesn't go beyond that. So if I were to want to integrate something with my system or between clouds, it's not possible because the identity of these systems cannot be accessed through clouds. The providers don't allow that to happen. So this is perhaps what made us think about something like Vault, which is the basic issue. We have to mediate identities. We have to be right in the middle, and we must understand how Amazon generates trust in an SO2 environment and how Google does exactly the same thing too, and then give access to other systems. So when we designed Vault, the basic principles we took into account is that we are assuming that there are multiple platforms in different systems, and this is not going to change. I've spoken to some of the departments of the British government, and they always spoke about Our dream is that perhaps we have only one identity layer in all of our computational resources, both in public or private codes, in VMware, and well, let's create only one layer of identity. And what I explained to them at that point in time is that lots of organizations have tried to do the same, because at the end of the day, when we use Vault, we are based on the principle that that is not going to happen, that we're going to have to trust multiple identities. And regardless of the identity we use to access a resource, at the end of the day, we're going to apply a policy to this identity, and I can do so in a programmatic manner. So I don't need a human being to become involved nor to do anything on the machine. The machine is initiated or started up, and we can check the identity to make sure if that machine is reliable or not. And the second principle is how we manage secrets. Basically, if I know who you are, because I can authenticate your identity and I know that I can apply a policy to your identity, it would be very complex to generate a secret. But as you can do so automatically, I can do it, can make it very short and do it very quickly. And I could put this in the perimeter that you require. If it's only read or only write, I don't have to do this, or I don't have to create this manually when this application is initiated. It depends on your AIM profile, or it depends on your role in navigation, but you just can obtain the credentials you need. Oh, access is temporary, because with this credential, it's very easy to obtain, and basically I can't really do very much, because if I need more credentials, well, I just have to ask for. There are no tickets involved in this environment. And in this manner, I can control access to information by staying outside the data flow. So I, as Vault, can give access to a system, and then I can withdraw and allow the application to interact with the database, just to give you an example. So I don't have to be in that critical data path. If Vault is not working, the app stops working too. And finally, the basic principle of limiting access to information. Access to information, generally speaking, is also managed physically. If any of you has administered storage systems, you know that basically this fiber is connected to this switch, and this logical unit, or this virtual disk drive, is exposed to this system. And this is one of the assumptions that has been used for cloud. If somebody makes a mistake, and if somebody can open one of these buckets or any storage system, as I read in the headlines of newspapers every day. So we have to secure information not only by means of what we call encryption at disk, but rather we have to encrypt the information that's in transit in such a manner that, for instance, what we generate in Vault is basically a system in which Vault puts away the storage keys, and the app encrypts information before storing it away on a disk or in a storage system provided by any cloud. And this is how we can even federate the user to make sure that the app only encrypts information when the user requires this. And we can aggregate that level of traceability to the information. So if the information is encrypted, when you access that information, there's an encryption operation. So we have a register. And I would just like to go through this very quickly. But we have customers at Amro Bank, and Amro is now the biggest bank in Europe that has been using these practices for more than 2 years. But going back to just-in-time access. So if we've used Vault to solve all the limitations as regards managing secrets and information, we then wanted to deal with the transport layer, because the model is the same. And we still have this implicit trust that is based on the networks. But another thing that we have noticed in the cloud is that basically we have so many different scales of networks that there are many collisions between segments. If somebody uses a commercial app by default, well, there's a certain commercial system that ended up with only 5 elements. So we cannot we cannot trust those IPs because these IPs are not related to a service, and this IP can change, and this IP can be excluded, or it can be reprogrammed, it could appear in another geography or whatever, or at a different scale. So the basic principle as regards administering data transport is, well, let's forget about IP addresses because we know that this already exists, but traffic has to go through an upper layer to IP. So when we establish security policies, you could not only have a firewall where we include rules of allowing or disallowing. This has to be based on something that is understood. So when we designed this, we said, well, let's create a real security system in a mesh network where practically everything can be flat or doesn't have to be flat. And Consul is going to be the nexus between these connected networks. But when you connect services, we're going to do so through the name of the service compared to the proxy. And what we're going to do is do the encryption and transport, and we're going to generate the TLS certificates. In other words, the development of the application should not become bogged down. It should be one of the capabilities of the platform. And the next principle has to do with understanding that although in certain platforms we can do this, between the platforms or between the different networks, there's always going to be traditional firewalls. So this should be a center that registers these systems, and we have to use other tools like Terraform to reconfigure, should it be necessary, these routers or routers, core routers, because after all, these this is where all information flows through. So perhaps this shouldn't be fully automatic. Perhaps this should be more reactive, and this is what we have implemented with Consul Terraform. And then there's another customer of ours called Criteo in France, and this dates back more than 2 years, with thousands and thousands of systems up and running. And finally, well, the final issue that we wanted to look into is how can we control access of people? And the basic principle is very interesting because all of us, especially in the last 2 years, well, perhaps we've become accustomed to working with VPN customers. And perhaps we can see how complicated it is to administer these VPN customers. Because what we are doing, after all, is extending a gigantic perimeter around a small user who is perhaps at home, when what we possibly should do is just give that user specific privileges. And this is the basic principle based on which we generate boundary. On the one hand, by eliminating the complexity of VPNs, of the private virtual networks, and give access to a simple tunnel that doesn't give him access to a complete network, but rather only the port that he requires to access information. And together with Vault, this access can be delivered just in time in such a manner that we've also been able to generate credentials for just-in-time apps. We can use this federated identity not only to provide access to only one port, but also to introduce credentials so that access can be provided to the service that the user needs without really having to generate any VPN tunnels or having any rotations. And we use as an identity anchorage the identity of the user, and then we know who the user is, we know what his privileges are, so this is how we can generate just-in-time credentials for whatever. And finally, what is it we are envisioning for Zero Trust? Perhaps I've applied this a lot to HashiCorp products, but there are other tools on the market that would allow you to do this. But our vision basically is that being a user, or if a user has to put away certain information, that the user can send the information to an app, and the app would then be able to go to a system where passwords can be obtained, just-in-time passwords can be obtained to access where the passwords have been stored, and then you can go to another platform or to Vault, and you can encrypt that information in such a manner that if there's an exfiltration, it cannot be interpreted easily. In the same manner, we want this app Well, we want the developers not to have to aggregate 15 tickets to the different network administrators whenever they have to do a redeployment or change the IPSs. In other words, that they use a persistent network or a mesh so that access can be given to the resources that are needed. And that this information be stored away and that it not be encrypted in transit, but also it's not only encrypted in transit, but it's also encrypted on the disk drive, which is where there's a very simple key management where you can add another level of encryption or another layer of encryption. But finally, if a user has to administer anything that has to do, for instance, the servers that are running the app or the database, well, they need to have a system where they have access only to the required port and with credentials that delivered or handed over to the user for a limited amount of time and that only provide access to what they require. This is a somewhat ambitious vision, if you want. But if I were to go back in time and I would look into what customers are doing nowadays, at least they are now starting with secrets management, which is perhaps the most important issue. So that means that with this, I would like to thank you very much, and I would like to apologize for having arrived late and for having had to limit the session a little bit time-wise. And I'm afraid that we had a technical issue, but well, I've been able to talk to you today. I hope that you've enjoyed the presentation. And now I'm going to go back to the chat and shortly, just in case you have any questions, unless Charles says that we can address your questions live. And if not, I'll just go straight to the chat. Yes, hello, Nicolas. Thanks a lot for your presentation. Sorry, we haven't got any live questions, and so many thanks for sharing your experience and your expertise with us. Everything was very clear, and I really enjoyed your lecture. And the truth is that we have to suffer these problems on a daily basis, and I think that the vision or the automation approach and of implementing all of these solutions is something that adds an immense amount of value to companies that have very large legacies and very complex systems, which is usually the case in this industry. So, many thanks once again for your time. Many thanks, and I would like to congratulate you. That was very good. Well, thank you very much, Charles. I'll see you. Bye-bye. Goodbye. Okay, we're now going to show a video as a transition until the next speaker comes along.